Quadratics Day 2. So once again, we're still sort of working on the basic building blocks of our quadratics with multiplying and getting more creative with what like terms mean when we start getting in more advanced math. Big thing to keep in mind here, once again, is our new definition of like terms. If you don't have this in your notes and it's a little confusing, I'd write this down. You must have the same variable and exponent. So now our rules with exponents are going to be even more important. So let's go into this more complicated problem. I see that there's nothing in between those parentheses, so I know I'm multiplying all of this together. And this is a much bigger problem, so I'm going to use the nice box area model to help organize it. So I know this has 2 items, so this side of the box is going to need 2 rows. And I know this has 3 items, so when I make my box, I'm gonna need 2 rows for the 3x and 1. I'm gonna need 3 options for the 2x squared, 5x, and negative 2, okay? And now we can start doing this. So right here is gonna be 3x times 2x squared. So we're gonna multiply the numbers out front, and then when we multiply, we add the exponents. We assume there's a 1 there. 1 plus 2 is x to the third. There are 3 x's being involved, so there has to be x to the third there. 5x times 3x, 5 times 3 is 15. And then when we multiply, we add the exponents that are on the same variable. So that's x squared. 3x times negative 2 is just negative 6x. 2x squared times 1 is just itself 2x squared. 5x times 1 is just 5x. Negative 2 times 1 is just negative 2. And now it's time to combine our like terms. Remember, it has to be the same variable and the same exponent. So I'm going to start over here. Is there another x to the third power? No, there isn't. So 6x to the third power comes into my final answer automatically. I'm going to sort of x that out so I know I've dealt with it. Now I see an x squared here and an x squared here. 2x squared plus 15x squared is 17x squared. Notice, guys, when I added, the variable didn't change. Sorry, the exponent did not change. Exponents only change when we're multiplying. So that's why when we were multiplying in these first steps, the exponents were changing. But if you're just adding or subtracting, like 2x plus 15x squared, we're just adding the numbers out front. The x squared doesn't change. I see a regular x and a regular x. 5x minus 6x is negative 1x. And then negative 2 is the only regular number in the problem. So the negative 2 comes at the end and we are done. Because we have no more like terms. That's the only x to the third. It's the only x squared. The only regular x. The only regular number. Now I'm going to throw in some more negative numbers because a lot of you guys are doing really fantastic thinking, but we're making some minor mistakes with our multiplying with negatives. So I'm going to once again use my nice area model box to set this up. So we have 4x minus 2, and then 3x squared minus 7x minus 8. Now we're ready to multiply. 4x times 3x squared, 4 times 3 is 12. When I multiply, we add the exponents on the same variable. We assume there's little 1s if you don't see an exponent. So 1 plus 2 is 3. 4 times negative 7 is negative 28. When one number is negative, the answer is negative. Then my x's give me x squared, because there's 1 plus 1 is 2. 4 times negative 8, when one number is negative, your answer is negative. And then that also has an x in there. Negative 2 times 3x squared, negative times a positive is a negative 6x squared. Negative 7 times negative 2, a negative times a negative is a positive 14. And this looks like there's only one x there. Negative times negative is a positive 16. And now we're ready to combine like terms. Once again, there's only one x to the third power in our options, so 12x cubed comes into our final answer. I see an x squared and an x squared. Negative 6 minus 28. When you subtract a negative, it's like adding the negative to be a bigger negative number. So we'll get to negative 34x squared. 14x minus 32 is negative 18x. And then that's my only regular number left, which is just going to go on to the end. Plus 16. And now I have my final answer.